Hello and welcome to our first Builder Hour of the autumn season. We hope that you've all had a great summer. My name is Greg Hamer and I am a Principal Developer Engagement Strategist at Infor. And I'm excited today to be joined by Inderjeet Singh, who is an Infor Senior Director of Decision Science and Engineering, and Yasmina Fiteska, who is our Product Manager of Infor's Artificial Intelligence Platform, which includes machine learning and data science. So I'm very excited for our session today for several reasons. First, because the services we are going over today are of use to all Infor ERP customers. Our focus is on the Infor Artificial Intelligence Platform, and we see it in use today by an expert in the hands of Inderjeet, whose team built on top of the AI platform to deliver Infor's augmented intelligence solutions, which Infor delivers to customers. Since they are both abbreviated AI, we will use AI to refer to the platform, artificial intelligence, which you can build your own custom solutions on, and AIS for the augmented intelligence service that delivers pre-built solutions that fast track your organization's getting the benefits of artificial intelligence. So Inderjeet will be demonstrating a custom algorithm, which is an advanced capability. So there are no prerequisites for this session, but it will be most entertaining for customers with experience with our artificial intelligence platform, whether they're using machine learning or optimization. And also for individuals with a background in mathematics or linear algebra. If you are new in these areas, it will still be entertaining as Inderjeet will use a personally developed example for recipe optimization. So we'll see that after we go through these introductions. Please note these sessions are recorded. So afterward, you can come back and re-listen to the session, particularly on YouTube. And let's just go and do quick introductions. First, Yasmina, would you like to introduce yourself?
Of course. Thank you, Greg, for the great introduction. My name is Yasmina Fiteska. I've been with Infor for almost 6 years now, and I'm based in the office in Prague, Czech Republic. I used to be the business analyst in development, and for the last 6 months, I've taken the role of product manager for the Infor Artificial Intelligence, or Infor AI shortly. And as you said, we have the pleasure of Inderjeet's company today. So Inderjeet, please go ahead, introduce yourself.
Thank you, Jasmina. Thank you, Greg. Good morning, good afternoon, good evening, everyone. I am Inderjeet Singh. I lead the Decision Science and Engineering team at Infor, part of the Platform Technology Group. I closely work with Yasmina, and I am one of her internal customer or adopter of Infor AI and Infor OS. We leverage Infor OS and Infor AI to build augmented intelligence solution that we offer to our customer at scale. We these these Using these augmented intelligence solution, we derive innovation for our customer. So I'm very excited to share what it takes to build one of such solution using one of the advanced capabilities called custom algorithm in Infor AI optimization. Great.
Awesome. And if this is your first time attending a Builder Hour, the concept here is that Builder Hours, what we're really looking for is your engagement, which is primarily through the chat. So just so that you can get acquainted with using the chat, if you could, please share what city you are joining from. And for reference, I'm coming to you from Las Vegas, Nevada, which will be the first of two host cities in October for our Infor Velocity Summit. Velocity Summit will be here in Las Vegas at the start of October, and then moving to Amsterdam for part two at the end of October. And again, if you could just pop in your cities, thank you very much. I think there's a little lag here too. Just so you know, Yasmina and Inderjeet and I can see your questions in chat. However, we will not be responding in chat. as an added value for you, the participants, we do have other expert team members who will be able to respond in chat. So at any point throughout this, if you have questions about uh, Infor's AI platform or Infor's augmented intelligence service or anything that we are bringing up as topics and discussing, please don't be shy. The point is enter your questions and comments in chat, and some of them will be responded to immediately by our team members, and some of them we will bring up and have Yasmina and Indrajit address. And for folks who are already working in the chat, thank you very much. It's always fascinating working with Infor, which is a global company, seeing that we have people coming in from around the globe. So as Indrajit said, good evening to those who are coming in from Europe, and early morning to those coming in from Southeast Asia. A second uh, question for chat, or actually before I go there, before we go any further, what we are going to be talking about are capabilities that are available to you today. And if through questions come up, I need to post this disclaimer that if through questions there are anything about future products, roadmaps, proposed dates, we just need to make clear we're not making any promises on those topics here in this episode. But again, Velocity Summit's coming in October, so keep your eye open. There'll be, I am very confident, a good number of amazing new features and capabilities that you will be seeing announcements of throughout the month of October. So let me just ask a second question to post in chat, and this is going to just be post a yes or a no to the question, do you have experience with Infor AI or specifically the Infor AI artificial intelligence platform? And with that, let me pass the microphone first to Yasmina. And Yasmina is going to give us an introduction to the platform. And then after she gives that quick overview, we will then pass the microphone to Inderjeet, who has got a demonstration that he will be delivering. So Yasmina, you pick up from here.
Yes, I actually wanted to start with a little bit of background about the product itself. So, Infor Artificial Intelligence was initially launched in 2019 under the name Coolman AI platform. And I'm mentioning this because I'm sure a lot of you here might be more familiar with this name. So, I wanted to emphasize that we're actually talking about the very same product that is now rebranded as artificial intelligence, and it is an integral part of the InfoRS technology platform. And up until about a year ago, the primary focus of the product has been the machine learning, or the area of predictive analytics and insights. This involves training, deployment, and use of predictive models that analyze historical data to predict future outcomes. In this area, we've had numerous solution implementations for our customers across all Infor Cloud suites, ranging from recommendation engines, anomaly detection, customer segmentation, various forecasting solutions in whether in retail, supply chain management, and so on, just to name a few of those from the entire portfolio. So, as the adoption grew, and through talking with our customers in order to understand their needs and problems, we actually identified the demand for natively supporting prescriptive analytics use cases, which is essentially the area of data science addressed by the optimization module that we recently added in the platform. So, unlike machine learning models that inform what will happen based on historical data patterns, here for the optimization models, we have provided prescriptive insights that answer the question of how to achieve something in the most optimal way or the best way possible, just as the name describes. So, mathematical optimization actually allows you to formulate a model that focuses on your current data and is in line with your business objectives. In optimization problems, generally, we're working with three main components. So we have decision variables. Those are the parameters that you can control in the problem. Then we have objectives, or the outcomes you want to achieve, such as to minimize or maximize a certain business goal. And lastly, we have the constraints that represent the limitations or the boundaries that must be respected when you're solving a specific optimization problem. And so, in real world scenarios, the complexity of all the involved factors actually makes it really difficult to find the best solution just by intuition or simple statistical analysis. And that's why we have optimization models to assist and search through the space of all the viable possibilities and identify the most optimal solution based on the objectives and the constraints that you define in the model setup. And this approach ensures that the decisions that the companies make are data driven and backed up with science.
So, Yasmina, that's a very important point that everything here is data driven. And that's where the Infor artificial intelligence platform in the OS platform is so empowering for all of our ERP users, because that's the point of data's origin, that transactional data, that real time data. What are some of
Mhm.
the use cases that um, this is most applicable to?
Okay, so let's take a simple example of packaging optimization for cost efficiency. So, in this problem, we want a solution that answers to a question: what is the most effective way to pack different products
Mhm.
into various boxes in order to minimize wasted space and reduce the shipping cost at the same time? So here in this case, the model takes into account the customer orders with all the different items in them. Then those items' dimensions or weights are also taken into account. Can be some special packaging requirements, like for fragile items or some items that must be packed separately for different reasons, and so on. And then the model matches these items with the available boxes, providing the optimal packing with the minimum wasted space, along with, of course, the shipping mode that results with the lowest possible cost. Or if we're talking on a larger scale, let's say in combination with a machine learning model, you have a sales demand forecast that predicted item sales in different regions for the upcoming year. So, following the forecast that has been provided by the machine learning model, the next logical business step would be to ensure that these items are available at the right locations and at the right time in order to meet the projected demand and maximize the profit. So optimization here can help you manage the stock levels across warehouse locations, considering the constraints of limited storage capacity. You have those always in the physical spaces, in the warehouses, then the shelving units, maybe some holding costs that you want to impose, and whatever you may have in your actual constraints. So the objective would be to maximize sales and revenue for each of those regions, and the model can calculate the optimal way to prepare for the upcoming season with the limitations of the company's resources and capacity and give you the best solutions for that. Some other typical optimization challenges can include, for example, optimal vehicle routing, where you're determining the most efficient routes for moving goods and services from one point to another, then optimizing of production schedules, energy distribution to minimize cost, and similar problems. So I think together, machine learning, optimization, and our newest addition, the decision manager module, which applies business rules to augment AI model outputs, all these technologies and tools are really revolutionizing the way our customers operate on a daily basis and plan for the long term. But you know how they say a tool is only as good as the skillful hands that use it. So I think it's a good time to give the floor to Inderjit and the super interesting demonstration he's been cooking for us today.
Before we dive in and I hand the mic back to Inderjeet, thank you for the feedback we were getting in the chat. And for a good number of people who have come in, this may be your first introduction to the Infor artificial intelligence functionality in the Infor OS platform. So just want to call out that we have got resources at our developer portal. And so if you go to developer.infor.com, you can see the developer portal. And there are tutorials. And also in chat, Jimmy Folks has posted a link to a cheat sheet. So that's another one of the resources you find on the developer portal. And that will help you fast track your development. But do understand that the teams at Infor, our cloud suite teams, are all bringing the power of artificial intelligence to bear wherever it is possible. So it's woven into the products in innumerable ways. What Inderjeet is going to demonstrate is another end of the spectrum where you could create your own, bring in your own custom algorithm. So he's going to be doing a more complex level than you might ever need to go to. And also his team with providing augmented intelligence services actually has got some solutions that you can use as well. But the focus on what Inderjeet's going to build will give you a basic introduction to how the artificial intelligence service works, with a focus on the optimization rather than the machine learning. But you'll see a lot of similarities between them. So your orientation for anybody new that you get by just staying in this and having Inderjeet walk you through how to use the tool. Again, we're seeing a powerful tool in the hands of a master in the field. And so I just want to call that out for people who are new. For people who are experienced, I think you're going to really enjoy. I think Inderjeet should have, maybe did have a career as a professor, because he's a very engaging speaker. So Inderjeet, I'll pass that over to you.
Thank you, Greg. Thank you, Jasmina. They are all very interesting problems that Jasmina you alluded to. Uh, so just trying to get a confirmation, Greg, if you can see my screen.
Just a moment. There we go. Yes.
Perfect.
Oh, I should also mention, now that Inderjeet's screen is up, the video box is at the bottom, so as not to distract from Inderjeet's demonstration. Either Yasmina or I, or both of us, may close our cameras. Don't be alarmed. We'll come back as you have questions. And also, as a heads up, what Inderjeet will be showing to the right will be the console. He'll be in there shortly. What he is showing to the left is specific because he's doing a custom algorithm. So he's bringing in Visual Studio Code, and he has all of the information there. Again, for folks who are mathematically inclined, I think you're loving what you're seeing on the screen already. So back to you, Inderjeet.
Thank you, Greg. So what we are seeing here on the screen, our left-hand side, is where we will be building, it's a framework, we will be building the recipe optimization custom algorithm. On the right-hand side, we will be using the platform to build an API. And we'll start with probably the end state to give you a flavor of what is the end product look like. But before we get started, optimization has a lot of application. We are going to discuss a more advanced feature, but just as a tradition, um, linear programming has its roots originating from the famous diet problem, um, known as Stigler diet. This problem was studied back in 1940s, has real applicability, but the most important thing is that it also influenced the development of simplex algorithm by George Danzig in 1945. So it's a tradition it's a textbook problem, and this was the first problem that was actually solved using linear program, the simplex method. So we're going to follow the same tradition. We are going to solve the diet problem, or a version of that called recipe optimization. And that is the motivation for us to showcase one of the advanced capabilities that we have right now in the platform. I encourage users to go and read these two articles, one by George Stigler, who was a famous Nobel laureate, and this is where he introduced the diet problem. And then this article by George Danzig from 1945, where he talked about how the things were connected that led to the development of linear programming and simplex method in 1945. So what we're going to do is, on in the Infor OS, we are going to go into the artificial intelligence application. Within the artificial intelligence, we know that we have features such as data collection, where we have datasets group. We have the whole machine learning module that is available to our customer. The recent addition to Infor OS is actually the optimization module. As an OR scientist, I think I consider the optimization as the bigger brother for machine learning, who just joined the party. And I'm very excited to have very advanced capabilities that my team and I are able to leverage to build augmented intelligence solution. We will look at one of that such solution. The solution is still relevant in industry, even though the recipe optimization can be a very complex problem, but at the heart of it, it is trying to balance the cost and the nutritional value. But in reality, it can be there could be additional complexities, such as you are also trying to achieve certain texture, taste, aroma, or you have some environmental and sustainability concerns that you need to address as you are building recipe. So it can be very complex problem. We're going to look at the very basic, or the heart of the optimization problem, which is balancing cost with with the ingredients we have to achieve the target value of the nutrients.
So, uh, Indrajit, sorry for interjecting, but one thing I also like to emphasize is Indrajit's going to be giving a demonstration of a very specific solution applying mathematics. But as Yasmina had gone through, there are applicability of this mathematical solutions to a wide variety of different use cases. So again, stick with Indrajit as he goes through, and if your problems are not specific to what he's addressing, many of our customers in food and beverage, this is just a foundational part of their business. But this does have applicability to logistics and packaging and a wide variety of different use cases. So this is a good introduction to understand one of the many use cases that this optimization can be applied to.
Yeah, and to add to that, Greg, even the math model that actually does recipe optimization, we are able to leverage the same model to do general class of blending problems. Um, Now, I know that the focus is on recipe. We have food that is running in our brains that when we talk about recipe, but the same model is applicable to do things like mixing the paint to achieve certain paint characteristics, where the ingredient becomes your binder, your paint and water, where the nutrients becomes your parameters, viscosity and all. It also has applicability in metallurgical processes, where you are trying to achieve certain metal characteristics, such as alloy. You're mixing alloys to achieve certain characteristics of steel. Now, the model itself has actually additional applications. So that is why this is what the OR scientists do. They are really good at finding uh, a core model that can be reconfigured for different type of business use cases.
Excellent. By the way, there is one question specific to the paper industry. Have you had any call to be support to our customers in the paper industry? He says paper is made into large reels. They go into the slider and then get cut into rolls. And can we use these type of solutions to determine what is the optimized method across, say, invoices and
Absolutely. So if I understood, cutting stock problem in paper industry, because these rolls like the toilet paper or the other paper towels are actually cut, and there are algorithms that are meant optimization, advanced optimization technique that can be leveraged. The platform allows us to build any algorithm. So yes, the answer is that if you know what kind of optimization technique you will be using, and it can be any algorithm. It doesn't have to be a math model. It can be a heuristic. It can be a simulation based technique, or it could be a mixture of machine learning and optimization. There are a lot of advancement in reinforcement learning, which is I consider that as an interface of machine learning and optimization, where you are trying to leverage the history as well to come up with optimal decision. So uh, I would say sky is the limit with the advanced feature we're gonna see
And
now.
one last quick question, and this is more toward Yasmina. There's a question about what licenses customers need to have to make use of the solution. Is there a quick answer to that?
Yes, there is. The customers just need to be subscribed to the Infor OS platform. And within every tier of Infor OS, Essentials, Professional, Enterprise, you have a certain amount of usage that you're entitled to within the artificial intelligence platform.
Awesome. Now we're gonna have to. We don't want to run out the clock here. We'll get to more
Absolutely.
questions at the
Yep.
back end, but
Yeah.
off to you, Interji.
Cool. So what we're gonna go do is we're gonna go into the optimization. We're going to look at the custom algorithm, and when you click on custom algorithm, this is where when you try to add a new one, um, you have this instruction tab, and let me bring this up. So we call it build your own algorithm or bring your own algorithm. What it allows the implementation. These instructions are available to all the user of Infor AI platform. The most important thing is that how you create a dev framework following these instructions is up to you. There is a one-time setup that you will need so that you can build solution. So the screen on the left hand side actually is one such dev framework that my team, my MLOps team, has given to me. Now we have to invest in these frameworks because we are building solution that can be deployed at scale. So we have to worry about CI/CD, we have to worry about unit testing, and a lot of other requirements. So we have invested our effort, but user can follow these instructions to set up a Docker, which is pretty standard. So there's a Docker file. It has a specification, and you can use that set of instruction to create your own dev framework. And we can have we if you so these instructions are pretty useful to get you started. So back to the custom algorithm. So if we all we have to do is we have to create a custom algorithm that I can leverage to build a REST API. I'm going to switch to the left of the screen, and this is a dev framework. We call it, there are make recipes that my team has given. So one of the recipe is make Orca, OR, operation research, and CA for custom algorithm. What it is going to do is it's going to build a like a, it's going to create that Docker environment, and it is going to give a package that I can then upload in this on the right hand side. So the what will what the package, it's going to take some time to upload, but that's fine. We already have one that we created, and to get the thing started, we are going to call it a recipe demo, and we're going to specify the location of the package. There is one that should be coming up in the dist folder. So let's give it a minute, right? and should be,
What, Inderjeet, while that's running,
yeah,
um, I'm sorry, there was a question that slipped by, but it was already answered. So there
yes.
was a question about whether the model could be used outside of um, the Infor platform.
All right.
Sorry.
So the package just got ready at 11:30. That's the time. We're going to upload that package. We're going to call it a recipe demo, and we're going to save it, and we are going to deploy, and it's going to get deployed very quickly. So please bear with me. And once it gets deployed, it is ready to be used. That's the now we will look at the buildings of the package as well. So for optimization, want to start with the data sets. This is a recipe optimization problem, and the data set that we are going to look at are the target weight. So in the food and beverage industry, it is very common to specify the parameters or the nutritional value per 100 gram of the ingredient. And that's why for the sake of the model, we are going to express the weight, the target recipe weight, or the portion that we are trying to achieve, or the yield, in multiples of 100 grams. So we have curated these data sets, and this data set can come from your upstream system. Could it be M3, PLN, any Infor ERP? So these data set can be curated. So for this model, we have target weight, and might be easier to look at the target weight here. We are setting it to 1, and we have also a list of ingredients, and the list of ingredient is nothing but what I can leverage to make my recipe. So since this is a personal recipe, this is the one that I use to make energy bars. I have all sorts of nuts and figs and honey. So when you have picky kids at home, this is what you end up doing. So this recipe is tailored for my customer needs, and it has some min and max quantities for the ingredients. For example, we look at ingredient, we look at its cost cost in USD for the weight, like the packaging it comes. So for example, almonds cost $26, and it's close to 2 kilograms or 5 pounds, 4 pounds packaging. Cost per 100 gram of almonds is 1.43, right? Now, in order to build a recipe, the food scientists have this lever where they can use their domain knowledge to describe in percentages what should be the min and the max they expect these ingredients to be. So
Um,
since, yeah,
Inderjeet, as we're going through this ingredients list, now, if my understanding is correct, you are the food scientist in this case, and your customer actually is your family. So this
yes.
is a recipe you actually prepare at home.
That is correct. I make like these are energy bars to keep kids whenever they need. So yes, that is indeed the case, and I did not optimize it. I It's easy for me to put that in a like take the servings. Um, as a ball. So I take equal quantities of all the nuts and everything, and then add honey to bind it, and sesame seeds to just coat it.
So,
It
but
looks
for
like,
our commercial customers, this is actually something that's really critical for the success in their business. The product inputs costs change, and for food science, this can have large dollar impact if in figuring out these optimizations.
cool.
In your case, you just want to make sure your family's happy, but
That is the requirement. So today morning itself, I was facing a situation where I was packing between figs and dates. One preferred figs, another preferred dates. So I have to put both of them in the recipe. So these are the examples that led to this recipe creation. Um, So after the ingredient, we also are interested in nutrients. So these are the parameters that we are trying to optimize or meet with our uh, with our recipe. So nutrients can be such as calcium. You have some requirements. You have some calorie requirements and some vitamins. So it's pretty common in the industry to have these requirements again specified per 100 gram of recipe, and we have those requirements listed here as well. I am looking for a healthy fats and energy bar. So since all these nuts are packed with the good monosaturated and polysaturated fat, I have certain requirement that I would like to achieve between 30 and 60. The last but not the most important one is ingredients contribution to the nutrient. So let's take almond, 100 gram of almond, how much, let's say, calcium it has. So on average it has 75 milligram of calcium per 100 gram, and it has 10 grams of fiber and so on. So this is the, for every ingredient nutrient pair, what is the nutritional value that ingredient contributes. So with this data set in this is what is going to go into the model, and we are going to create a model here. So I think what we'll do is we'll start with the end product. So the end product is an endpoint, and we, for us it is the recipe optimization endpoint. uh, and so let's see. So once this endpoint is up and running, we can use a test case. So in this example, it is the test case that we have created.
Yeah, it's not often we see home recipes being presented in a JSON format. So
Absolutely. So what the optimizer did is it solved the problem right in on demand and in real time, and it ended up creating a recipe, which is the recipe I had, of equal amounts of nuts and 5% of honey and 5% of sesame at a cost of 1.63 per one portion. Now, this 1.63 can be million or billions of dollars. One portion can be tons of product that you are making at industrial scale. Now, uh, so this is already a recipe that I was enforcing. But in general, when you are starting from a clean state, it is very common for a food scientist that, well, I don't know what is the art of possible. I'm going to set these minimum and maxes to between 0 and 100. Okay. So this is exactly what I'm doing right now. I'm setting, I'm pretending that I'm a rookie food scientist and I don't know what the optimizer can do. I'm going to set these min and max for the ingredients to a range of 0 and 100, since they are specified in percentages. So once I do that, remember that it was 163 as the total cost. So once we set it to 0 and 100, what we are seeing is we should be able to see a new recipe which has one portion of the weight. Now it costs actually only $1.30. Uh, this is 20%, close to 20% reduction in the cost, and we want to also verify it warrants that whether this recipe even meet our nutritional requirement. So so these were the nutrients that we were targeting. We wanted the calcium to be between 50 and 100 per 100 gram. So let's look at that. So calcium is indeed in the range, and you can verify that the calories are in range, carbohydrates are in range, and so on. Now, let's look at the recipe. Yasmina, what do you think about this recipe that only has pecans and dates in it?
Well, if you're asking me, I surely don't like this optimized recipe for a simple reason: there's no chocolate in it anymore.
Okay, so
I
uh,
know it's cheaper, but
that
just
is
build
not
back
cheap.
the chocolate in there.
Yes, chocolate was actually dark chocolate. The one that I use actually was the costlier item on the list, and I forgot I did not turn the sunflower kernels. They probably are still showing up as 10%. So for Yasmina, since she likes chocolate, and my customer also, they chocolate is their requirement. So we want to enforce at least 10% chocolate, and we can rerun this again. um, and we will get a new optimized recipe where we can hide the runtime data. Here it is. So it is $1.36 now. Chocolate has been added 10% since it is one portion, so 0.10 is 10%, and it has respected. And you can also verify that it has also met the nutritional requirement. Now, what I just described, back and forth, and this is pretty normal in the food industry to optimize, to tune the formulation, that lends itself to a high level architecture where the data is coming from an upstream system such as PLM, M3. It goes into through data fabric to the data lake objects that we showed four data lake objects in the previous screen, where we can build an optimization quest, and that quest will, once completed, will expose an REST API endpoint that can be consumed back and forth in a downstream system. Now, the upstream system and the downstream system can be the same in for ERP application. Upstream could be some data that is in your warehouse as well. But the arrow back and forth in this architecture are telling you the back and forth, the on-demand nature, where you can make an REST API call, you can get a new updated recipe, and once you are happy, you can actually finalize and then you can put it into production.
And Indrajit, with this diagram is one of the things that I've been building information systems throughout my career. I especially love about the cloud because when Indrajit's highlighting, each one of these components is already up and operational. It's available for Infor customers. And so as complex as some of these solutions may seem, we at Infor have greatly simplified it for our customers. So all of the integration work is done. All these systems are up and they're highly operational and scalable. So this diagram is kind of a capstone of the power of the cloud and using Infor systems.
Cool. So we want to go back and we want to build our quest, the new recipe optimization quest from scratch. Now that we have seen what is the end product, so what we're going to do is we're going to start with a data collection first. So there's a new feature called groups, and that is I found it very useful. We're going to create a new data group. We are going to call it recipe optimization group demo. And for this group, we have to add the four data sets that we have. What I found it easy, since I updated recently, I am looking for the weight, the ingredients, nutrients, and the nutritional value. Save it, and that has created a logical group that is now combining these data sets. So I have a data set group already created called recipe optimization group demo. I'm going to go into the optimization uh, uh, module, and I'm going to create a new recipe optimization quest. We're going to call it recipe optimization demo. It does require a data collection. We have created the new recipe optimization group demo data set just now. We're going to save it. So Infor AI optimization follow this swim lane architecture where you have data. We're going to hide. We don't need any. We have offloaded all the pre-processing to our advanced algorithm, and we are going to bring a custom the algorithm. So we have an existing expression builder that you can leverage as well. We are going to, for this purpose, we are going to use an advanced custom algorithm. We created one called recipe demo. We're going to specify a name. We're going to call it, let's say, demo as well. We're going to save it. and we are the moment it is saved, you get these two boxes, which is optimized model and result. We're going to let it run. Okay, so this will take about 5-10 minutes to complete. Once
And
it is complete, yeah.
Inderjeet, while that's up on the screen, since there were a significant number of people who may not have worked on doing optimization before or even used the machine learning, what Inderjeet described as the swim lane architecture, you'll note along the bottom that it indicates what each one of the steps in the quest are. So the data set collection, the setup model. And so this is a metaphor that you're going to see working inside of the Infor AI architecture, and it can be very helpful in following along as Inderjeet finishes this presentation. And it's
Cool.
still running. Am I correct, Inderjeet?
That is correct. While it is running, we are going to go in further details. So we're going to focus on the left hand side. Um, so again, dev framework, but what this model requires is for OR scientists, it is pretty standard to write the model in a mathematical notation in Greeks. So it's a pretty standard way to specify the model that starts with sets and indices. Here we have two dimensions, one for ingredient, one for nutrients. We have data, or scientists like to call them as parameters because these are input. Now, this data can be derived from history. So, in general, for example, uh, the nutritional value, nutrition value, there are different types of almonds, but you may have to deal with some sort of average, the type of almonds you have. So, you can look at some data to come up with the nutritional value estimate. Now, the parameters, as we have discussed, we have target recipe weight, we have cost per 100 gram of each ingredient. This one is the most important, where you want a desired min and max of each ingredient. And we have a desired min and max of every nutrient. The only difference here is that the ingredient, since the food scientists are, it's easy for them to think in terms of percentages rather than exact absolute weight. So that is why they are described in percentages. But the parameters are absolute values, so you have to specify them per 100 gram of the recipe. Now, the most important thing here is you need to know what your decision, what are you trying to optimize? And the decision variable here is the weight of the ingredient. And our objective function here is nothing but trying to minimize the cost of the recipe. And we want to make sure that we achieve the target recipe weight. Now, this constraint itself actually distinguishes the problem, the recipe optimization, from the traditional diet problem. Because in the traditional diet problem, you are trying to balance the cost to achieve nutrients, but uh, uh, the output of the diet problem, you can use the ingredient list to make any number of recipes. But in the recipe optimization, you are looking for a recipe, so it's a special case of the diet problem. And then we have some min max ranges that are expressed as constraint, and we will quickly see that in the code as well. I need to jump to the right because my design quest finished. I want to make sure that the results that I got is what I was expecting. So remember, this was a test case with the recipe I had. I was expecting 163. I got that. I have those ingredient quantity. They look good to me. The model is ready to be deployed. I am presented with two options. Either I can do a batch or a real time. My need for this optimization use case is for real time. So not all optimization problems are meant for real time. Some of the problems that Yasmina talked about, production scheduling, packaging optimization, they tend to be hard, notoriously hard. They will take more compute power. For those, left hand side is the right choice for you. For this problem, since it is linear, and the linear programs generally are faster, but the most important thing is this instance. The instance is pretty small, where you have limited ingredient nutrients that you can play with. So we're going to pick real time because that's what we will be needing. It'll take a minute to create the production quest. So while the production quest, real-time production quest now has been created, the only thing we need to do is we need to go to the optimization model. We need to specify the schema of our REST API, and the schema is dictated by the purple boxes. And the purple boxes, they have the parameter that we can select is the table name or the data set name and the column name. So target weight has a column called target weight underscore 100 100 gram. So what we're going to do is for the ease, we're going to select all. We're going to push it to the right hand side, and then we want to verify as well. So this is the JSON schema that will get created. We're going to save it, and we are going to save one more time, and we are going to run the real-time production quest, right? So once this real-time production quest will finish, we will have something that we can easily deploy as a endpoint. While that is running, we're going to let it run. We want to see what it takes to translate this algebraic formulation in a piece of code. um, there are many choices you can do. It's a dev framework. For simplicity, I decided to use a Jupyter notebook, which is pretty common for data scientists to kind of try it out. And once that code, you are happy with the code, you can transfer that code into a more cleaner code that you can deploy. That is what we are deploying on the right hand side. So so the Jupyter notebook over here is doing nothing but it is dealing with four inputs, the data sets. It is loading them as a dictionary. So the very first element of the optimizer function that is described in the documentation, it expects a dictionary whose elements, whose keys are the name of the data set, which is four of them, but whose elements are the values are actually pandas data frame. And that is exactly what this function is trying to curate here. So we verify that our dictionary has been created correctly, and we now try to implement the model. You can implement using any framework. For this, we are using OR tools. We are invoking CBC as the solver. Um, in this section, we are declaring our decision variable, which are our x's. And as we declare our decision variable, we also can specify the lower and the upper bounds. So solver.numVar, it takes arguments, three arguments, where you can specify what is the minimum value, which is the percentage. Now this percentage, if you notice, for the ingredient is converted into an absolute value. And then you have the constraint where you are making sure that everything put together achieves the yield, and that is our target weight constraint. Then we have constraint for achieving the nutritional value. So this section over here says that for every nutrient ingredient pair, for every uh, nutrient, I want to make sure that the sum of the contribution across all ingredient meets my nutritional value, right? So the most important thing I recommend all my fellow OR scientists to ensure is that make sure you are printing the math model. Once you print the math model, that is one way for you to verify that your math model is doing what you expect it to do, right? So this is something that you can verify. Once you are happy, you are back to the packaging, and you have multiple ways. You can create your own dev framework to package. And once the package is done, this is where you can leverage the custom algorithm. Now, the right hand side, the quest finished, the design production finished. All we need to do is we need to just create an endpoint. Endpoint got created. It's a recipe endpoint demo, and we are ready to test it now. So this is where we started. This is a new endpoint that we were able to create on the call. We're going to take our test case. This is the recipe that should give us 163. This is the optimized recipe. Uh, and we have that recipe over here. So this is from where we started, and this is where we are now successfully able to see how we can leverage Infor AI's new optimization capability to solve recipe optimization problem. So I hope this gives you enough motivation to try out this new advanced functionality. And we are there. We are happy to help if you have any questions.
Excellent. And thank you, Inderjeet. There was a question that I think your demonstration answered, and the question was being able to call the endpoint from, is the REST point enabled and can it be accessed from outside of Infor OS? And I think you've clearly demonstrated yes.
That is correct. We can. So this was the. So if you can see my screen, one more time. Yes. So what
Yes.
I was demonstrating was this inbuilt functionality within the Infor AI. But the right way to integrate the endpoint is using Ion API. And this you can, once you authenticate using proper authentication, you can leverage the optimizer endpoint within your Ion. Sorry, in the API gateway, you can leverage that endpoint with proper authentication.
And then to Yasmina, what would you suggest for customers who may be taking their first steps into using the artificial intelligence platform?
Well, I would suggest to not be afraid to try out things. We have all the tools that are needed for machine learning and optimization use cases. You can apply business rules efficiently to your models that you produce in our platform. However, there's always the option of subscribing to the augmented intelligence service that are doing wonders for our customers and working on end-to-end solution use cases that are just readily made available and uh, consumed by our customers.
And Inderjeet, because nobody knows the augmented intelligence services better than you, might you be able to give a quick synopsis on how that solves solutions? There you go.
Yes. So the augmented intelligence service. So I build the solution. So I call it augmented intelligence solution, but they are offered as part of the AIS augmented intelligence service. I think the key thing here is that we are looking to innovate with our customer and using the technology they already have, and the key thing here is that the focus is always on delivering business value. It's not about the cool ML or OR models we can offer, but it is about user front and center. The word augmented actually is because we always consider human in loop. Business user are always in charge. They will get a recommendation that they can use as a starting point. Now, if you can bring up, if you can see my screen, uh, under our platform, we have the AI ML capabilities. So this is what Yasmina represents. Augmented intelligence service is also there underneath, and these two together are much powerful combination for our customers to innovate with the cloud suite. Now, if you look at the AI ML, this is what Jasmina was alluding. We have variety of solution we can offer out of the box uh, to our customer, and these could be demand forecasting, this could be asset maintenance, could be improving efficiencies such as um, recipe optimization, or using the forecast to optimize your inventory level. We have pricing. We can optimize the price, or we can recommend the right price, and we can also do customer segmentation and solutions such as product recommendation.
Excellent. Well, with that, we're at the top of the hour. So I want to give a very heartfelt thank you to Yasmina and Inderjeet. This has been very interesting. For folks who this might have been your introduction to this space, the capabilities are there. Infor gives you the ability to bring the benefits to your data. So remember, no organization has your data, and what these technologies enable is you're being able to get competitive advantage, cost savings, efficiencies in your organization. And so it's well worth understanding how to bring them in, and we have different tiered levels. So talk to your contact at Infor, and they will help you get back to Inderjeet and Yasmina and their teams and figure out the best path for you to bring these capabilities to bear on your business problems. And do remember that we have the developer portal, which you can go to get additional information. So that's at developer.infor.com. And we have that YouTube channel. Much of the content on the YouTube channel is also linked inside of the developer portal. So as you go through tutorials, you'll often find the step-by-step instructions, as well as a YouTube video that will show you them being implemented, similar to what Inderjeet was doing here today. And this event was recorded, so you can go back to that, hit pause, rewind, fast forward, and get back to the information that you need. So I know there were some other questions. Sorry we didn't get to all of them. But again, thank you very much, Inderjeet and Yasmina. And thank you all for joining us. Thank you for your time.
It was a pleasure.